In this video, we're going to look at the derivatives of the inverse trigonometric functions. Now, one just quick note here that most texts will interchange these two types of notations when dealing with inverse trigonometric functions, whether or not it's the exponent of -1 or the arc notation. They do mean something different, but most people don't stress about it, and they really do use each other, each one interchangeably. So I just wanted you to be aware of that before we move on. Similar to the trigonometric derivative video, I have stated all 6 functions over here to the left, and then their corresponding derivatives to the right. Remember again that similar to the trigonometry function, if that is our inside function, there it is right there. And then we also need to tack on that x prime because of the chain rule. Again, I'll show you with an example down below. And then one last similarity, anything that starts with a c or the co, again has the negative derivative. So if we look at arc cosine, it has a negative derivative, arc cotan has a negative derivative, and arc cosecant has a negative derivative. Now, looking at my first example, inverse sine. So the derivative of inverse sine of something is 1 over the square root of 1 minus that something squared. And then we multiply that by the derivative of the inside. It's in 2 terms, so I need to put it in brackets. It is just a power rule, so 3 times 4 is 12. Subtract 1 from the exponent, and then the derivative of x is 1. Looking at my second example, I can see that I have 2 terms here. I have one term here, which is a quotient, and then a second term. So I will apply the derivative operator to both terms. Looking at my first one, which is the quotient, I'm going to take the derivative of the numerator. That gets multiplied by the denominator, as is. Take away. Then I'm going to take the derivative of the denominator. The derivative of arctan is 1 over 1 plus that something squared. Then I'm going to take the derivative of the inside. The derivative of 9x is 9. And then that gets multiplied by the numerator as is. And then that term is all divided by my denominator squared. Now moving on to arc cosecant. It is a term that starts with that c or that co, so it is going to be negative. And then scrolling up quickly and looking at arc cosecant, I can see that it has this very interesting derivative. It is definitely not one that is commonly used in mathematics, but it does exist. So it will be -1 over the absolute value of that argument. So that is 5x cubed. And then that gets multiplied by the square root of that argument squared minus 1. And then all of that gets multiplied by the derivative of the inside, which is 15x squared.